Right now, in the galaxy 160,000 light-years from Earth, known as the Large Magellanic Cloud, one of the largest objects in the universe is dying. This is WOH G64, a red hypergiant whose thermonuclear fusion has completely lost stability. At the end of 2024, astronomers obtained the first detailed image of this star using the VLTI interferometer. They discovered that it's rapidly shedding its outer layers, forming a dense, elongated cocoon of dust around itself. This is nothing other than the star's flesh, which is being violently ejected into space by internal radiation pressure. The scale of WOH G64 goes beyond human comprehension. Its radius is 1,540 solar radii, equal to 665 million miles. If this monster were at the center of our solar system, its outer boundary would engulf the orbits of Mercury, Venus, Earth, Mars, and even reach Jupiter's orbit. Despite shining about 450,000 times brighter than the Sun, the star in question is in a state of terminal collapse. Every second, it loses millions of tons of mass as it prepares for its final collapse. Its final explosion will be a catastrophe on a galactic scale. When the core fuel runs out, the resulting supernova will be so powerful that for several weeks it will outshine the entire host galaxy, brighter than billions of stars of the Large Magellanic Cloud combined. The explosion will be blinding and unimaginably powerful, after which gravity will collapse the remaining mass inward, turning the remnants into a black hole. But for now, WOH G64 is just a starting point. In the depths of space, there are titans that make this hypergiant seem small in comparison. We're about to ascend through the list of the most massive and dangerous stars, each new one revealing the insignificance of our Sun in the face of the true keepers of this universe. We begin with one of the most famous stars in the night sky, Vega. Located 25 light-years from Earth in the Lyra constellation, it appears to be an example of stability. However, its physical properties reveal how quickly the Sun loses dominance in comparison. Vega's radius is about 1.2 million miles, which is 2.8 times larger than that of the Sun. If placed at the center of our solar system, not only would it instantly engulf Mercury, it would also reduce all life on Earth to ash with its intense radiation. It has a mass twice greater than the Sun, and with a rotation speed of 147 miles per second, it flattens at the poles into an oblate shape. Surface temperatures reaches 9,600 degrees Celsius, producing 40 times more energy than our home star. However, these metrics pale in comparison before our next object, a star in the Gemini constellation that belongs to a whole new weight class. The brightest star in the Gemini constellation, Pollux, is located 34 light-years away from Earth. With a radius of about 4.3 million miles, this orange giant is almost 3 times larger than Vega, and around 9 times the Sun's radius. If it took the position of our Sun, it would turn the inner circle of planets into molten rock. Although cooler than the Sun, its enormous surface emits 43 times more energy. It's a dying star that's exhausted hydrogen in its core and began rapidly turning into a sphere of loose gas. Pollux is a great example of a star that loses density in favor of volume, but even this orange giant is but a shadow compared to our next subject. The Taurus constellation is dominated by Aldebaran, also known as Bullseye. This orange giant is almost 5 times larger than Pollux, its radius reaching 44 solar radii. Placed at the Sun's position, it would extend halfway to Mercury's orbit, instantly sterilizing the planets of the inner solar system with extreme radiation. The photosphere temperature is 3,637 degrees Celsius, giving the object its characteristic crimson color and making it 425 times brighter than our Sun. Aldebaran constantly ejects streams of charged particles, creating a powerful stellar wind that carries the star's mass out into open space. What makes this object unique is that the automated probe Pioneer 10 is currently heading toward it. The spacecraft was launched back in 1972, but there's no point waiting for its survival, because it won't reach this star system for another 2 million years. At the moment, the giant has exhausted the hydrogen reserves in its core and begun to expand, preparing to shed its outer layers in the future. This process will eventually turn it into a white dwarf, surrounded by a planetary nebula of gas and dust. We move to the constellation of Orion, toward a star named Rigel, a blue supergiant located 860 light-years from Earth. Its physical radius is approximately 33.7 million miles, which is already 78 times larger than our Sun's. Aldebaran already seemed enormous with its 44 solar radii, and Rigel surpasses it, nearly twice the size in linear metrics. If it replaced our Sun, Rigel's gravity and ferocious ultraviolet radiation would instantly destroy all life on our planet. From Earth's surface, Rigel would appear as a blinding giant, occupying a significant portion of the sky, almost a quarter of the space from horizon to horizon. Despite its enormous volume, unlike the previous giants, this star has a monstrous mass equal to 21 suns. Its surface temperature reaches 11,700 degrees Celsius, which also means it shines 120,000 times brighter than the Sun. This is an example of extreme stellar evolution, where gigantic luminosity is combined with colossal physical size. Rigel is a dazzling opening act to the hollow supergiants that come next. At the center of the Milky Way, hidden beneath a dense veil of dust, there's another gravitational monster known as Pistol Star. This blue hypergiant, located 25,000 light-years from us, exists in the extreme conditions of the dense quintuplet cluster. If Rigel seemed inconceivable to you with its radius equal to 78 that of the Sun, then Pistol Star exceeds that scale by nearly 4 times. Its physical radius reaches 130 million miles, making it 300 times larger than our Sun. What makes this object unique is its monstrous brightness. According to our scientists, the Pistol Star shines an unbelievable 1.6 million times brighter than the Sun. Some data even suggest values up to 10 million times brighter than our star. If placed at the center of our solar system, its scorching plasma would engulf the orbits of Mars, instantly burning the solar system with intense radiation. Every second, Pistol Star ejects enormous masses of matter into space, forming a gigantic nebula around itself. But now, let's forget about stars that are merely dozens or hundreds of times larger than the Sun. Ahead of us are objects so enormous and dangerous that it will take real effort just to comprehend their scale. In the upper left part of Orion, where the celestial hunter holds his shoulder, is an object that makes Pistol Star look like an intermediate stage of stellar evolution. This is Betelgeuse, a red supergiant almost 2.5 times larger in size compared to the previous leader. Its physical radius reaches an immense 330 million miles, which is effectively 760 times larger than our Sun. If you replace the Sun with this monster, its outer boundaries would instantly swallow the asteroid belt, turning the inner solar system into a scorched wasteland. The streams of superheated plasma on the surface of Betelgeuse are so unstable that the star constantly pulsates, preparing for its final act. But here's something deeply unsettling. Scientists believe this star may have already exploded hundreds of years ago, and the light from that explosion is still traveling through the cosmic abyss. If that's true, then right now, as you're watching this video, an announcement of its death is already racing toward Earth through the darkness of space. When the light from this supernova reaches Earth, it will be so blinding that for several weeks it will be brighter than the full moon in the night sky, turning night into day. But behind this brief magnificence lies the inevitable birth of a gravitational predator. All of that colossal volume of gas will collapse inward, forming a black hole. What currently occupies hundreds of millions of miles in space will be compressed into an ultra-dense sphere only 20 miles across. This is the first destination on our list where matter officially loses the battle against gravity, creating an invisible anomaly in the fabric of space. At the same time, there is another pulsating object deep within the constellation, Cepheus, Cephei A. Its physical radius is approximately 454 million miles, which is effectively 1,050 times larger than our Sun. The scale of this star is on an entirely different level. This red hypergiant significantly surpasses Betelgeuse, pushing the boundaries of its stellar matter to previously unimaginable distances. If this titanic sphere were placed at the center of our solar system, its diffuse surface would instantly engulf Jupiter's orbit, reducing all of the inner planets to ash. What makes this star unique is its binary system. There's a smaller but extremely active blue star nearby. Because of the colossal size of the larger star, gravity on its surface is extremely weak, allowing its superheated gas to flow toward its smaller companion. As a result, Cephei A is surrounded by a gigantic cloud of its own escaping plasma. It's a vivid example of how matter loses density in favor of volume, transforming into a loose and highly unstable sphere that's barely held together by its own gravity. At this scale, stability becomes a luxury. Giant stars inevitably become diffuse and unstable, and the next object in the same constellation is a striking example of that. This pulsating deep red color belongs to Mu Cephei. This giant pushes the boundaries set by Cephei A and establishes a new record among the previously listed objects. Its physical radius reaches 544 million miles, which is about 1,260 times larger than our Sun. If this crimson sphere were placed at the center of the solar system, its outer boundary would extend far beyond the orbit of Jupiter, almost reaching the rings of Saturn. The intense red color of Mu Cephei is caused by its low surface temperature of only 3,400 degrees Celsius, nearly 40% lower than the Sun's surface temperature. The cooler the star, the more its radiation shifts towards the red part of the spectrum. At first glance, it may appear only slightly brighter than the Sun, but this is misleading. It has a luminosity that surpasses our Sun by about 350,000 times. This makes it one of the brightest and most recognizable objects in the night sky in the Northern Hemisphere. Mu Cephei constantly pulsates, changing brightness and ejecting enormous clouds of dust into space, which over time will become building material for new worlds. But even this supergiant loses in scale compared to our next subject. This is VY Canis Majoris, a star in the Canis Major constellation located 3,900 light-years from Earth. This red hypergiant exceeds the scale of Mu Cephei by almost 13%, reaching a radius of 1,420 solar radii, or 613 million miles. If it were to replace the Sun, its scorching surface would fully engulf Jupiter and reach Saturn's orbit, turning the inner solar system into ash. The photosphere temperature here is about 3,217 degrees Celsius, giving the star a dim reddish glow. While our Sun is expected to stay stable for about 10 billion years, this titan will burn out in just 10 million years due to the extreme rate of fuel consumption in its interior. But what's most remarkable is the extreme process of mass loss. Each year, it ejects a colossal amount of material, equivalent to 30 times of Earth's mass. These violent outflows create complex arcs and loops around the star, making it look like a glowing flower in empty space. But even VY Canis Majoris is not the largest among hypergiants. Some stars extend even further beyond the limits of stability, approaching the final stages of stellar evolution. Imagine 14 red supergiants all packed into a tiny region of space. We're entering the heart of the Milky Way, into a cluster known as RSGC1, to observe the largest and most interesting object there, RSGC1 F01. This Titan has a radius of 1,530 solar radii, equal to 660 million miles. At this size, if placed at the center of our solar system, it would engulf Jupiter and reach Saturn's orbit. The photosphere temperature on RSGC1F01 is 3,227 degrees Celsius, producing a deep red glow that penetrates dense interstellar dust. Due to its extremely low mass, this giant will only last a few million years before collapsing in a powerful explosion. Research shows that this star resides in an unusually dense stellar cluster with one of the highest levels of matter concentration in the galaxy. Leaving this stellar metropolis behind, we move toward the outskirts of Cepheus to a celestial object with anomalous behavior that forces scientists to reconsider the laws of stellar evolution. At a distance of 11,500 light-years from Earth lies RW Cephei. This orange hypergiant exceeds the previous Titan by only 0.3%, reaching a radius of 1,535 solar radii, with a physical outer boundary stretching across 667 million miles. To even begin to grasp the colossal scale of this object, consider that it takes only 14.5 seconds for light to travel around the Sun, whereas it would take more than an hour and a half to circle RW Cephei. The surface temperature out here is 3,194 degrees Celsius, which colors the surrounding void a menacing red tone. Due to its extreme mass, this object will only last a few million years, existing in a state of continuous breakdown. In 2022, RW Cephei shocked astronomers with a major dimming event, ejecting a massive cloud of material into space that formed an opaque dust shield. The star effectively expelled an amount of matter equivalent to the mass of several planetary systems. It's not a stable gas sphere, but a pulsating chaos, losing coherence as we speak. It may appear as though the dimensions of this star go against all known laws of physics until we move to our next celestial body. The next case is even more odd and extreme. At a distance of 11,500 light-years from Earth lies Westerlund 126. This red supergiant exceeds RW Cephei in size by 3%, with a radius of 1,580 solar radii, spanning across 682 million miles. If it took the place of the Sun, it would immediately engulf Jupiter's orbit, with its outer atmosphere reaching as far as Saturn. The photosphere temperature of this star has dropped to 2,727 degrees Celsius. For reference, the surface of our Sun is twice as hot. This produces a deep, somewhat dull glow among neighboring stars. The star is in a final stage of activity, with a remaining lifespan estimate of a few million years. The main feature of this object can only be detected in radio wavelengths. Astronomers were able to determine that Westerlund 126 is encased in a vast nebula of ionized gas. Powerful ejections of plasma from a glowing cocoon around a star's photosphere, visible through the dense clouds of stardust. As we continue our journey through the interstellar expanse, we approach yet another record-breaking Titan. At a distance of 9,500 light-years from us, the Scutum constellation is home to UY Scuti, considered the largest known star until recently. This red supergiant exceeds the size of Westerlund 126 by 8%, reaching a radius of 1,708 solar radii, spanning 738 million miles. This star is so huge, it could contain nearly 5 billion suns. To help you realize the colossal scale of this giant, imagine if the Sun were the size of a tennis ball. Against it, UY Scuti would scale to a sphere 374 feet in diameter, exceeding the length of a football field and the height of a 40-story skyscraper. Placed at the center of our solar system, it would fully engulf Jupiter's orbit, with its outer photosphere extending to Saturn. Its surface temperature is 3,092 degrees Celsius, making it appear dim, and yet its luminosity is still 340,000 times higher than the Sun's. Due to the extreme rate of helium burning at its core, it will only survive another few million years. The star lacks a clearly defined boundary. Due to its enormous size, the gravity is so weak that its outer layers constantly flow into space, forming a dense smoke screen made of scorching hot dust. The factual size and brightness of this hypergiant is constantly changing, a pulsation with a cycle of 740 days. It's hard to believe, but despite being 1,708 times bigger and 340,000 times brighter than the Sun, the mass of UY Scuti is only 10 times higher than the Sun's. And now we're approaching the finish line, heading toward an object that currently holds the record for the largest known star in the universe. Waiting ahead is a true stellar leader, a star with a size that seems mathematically and logically impossible. There are 20,000 light-years between us and the Stephenson 2 cluster in the Scutum constellation, home to Stephenson 218, the final boss when it comes to stellar size. It exceeds UY Scuti by 26%, with a radius of 2,150 solar radii, equal to 929 million miles. It's difficult to comprehend, but this gigantic sphere could fit 10 billion suns inside of it. If this enormous flaming sphere were placed at the center of our solar system, it would completely engulf Jupiter and Saturn, reaching the boundaries of Uranus's orbit. At that scale, the entire inner region of the solar system would become a zone of superheated plasma, erasing any trace of planetary matter. The scale of this star corresponds with extreme physical characteristics unlike anything else in the universe. A beam of light that can circle Earth 7 times in a single second would need around 9 hours to complete just one full trip around the equator of this monster. Whereas if you took an ordinary passenger airliner traveling at 560 miles per hour to take a trip around this star, the journey would last over 1,130 years, equivalent to dozens of generations of crew members changing over during a continuous voyage. The surface temperature here has cooled to 2,927 degrees Celsius, giving this giant a deep red hue typical for supermassive celestial bodies on the verge of thermal stability. Its incredible luminosity is estimated to be 440,000 times that of the Sun. The density of matter at the outer edges of this sphere is millions of times lower than the density of Earth's atmosphere, which means that this star is a loose, superheated cloud barely held together by the weakening gravity of its enormous core. Stephenson 218 exists at the theoretical Hayashi limit, a critical boundary beyond which further expansion of matter becomes physically impossible for any stable star. There are 26 other red supergiants within the Stephenson 2 cluster, but none of them come close to this truly incredible monster. Stephenson 218 represents the final stage of stellar evolution, followed by inevitable gravitational collapse. Because of its monstrous mass, the giant will only survive in this form for a few 100,000 years before exploding in an extremely powerful hypernova, blinding our entire galaxy. In the end, this colossal object will transform into a massive black hole that will consume light and surrounding matter for trillions of years.